Hi everyone, my name is Aryan and I'll be taking over the GK and GS part. Our first topic will be force, pressure and density. So what is force? Force is any push or pull that changes the position of body or tends to change it. Whenever we apply force, like a push or a pull in simple terms, when you move a coffee mug, when you push your cycle, when you drag something, it's all force. You are pulling or you're pushing. We have a unit of force in which we measure it. Like you measure water in your glass. We measure force in a simple term. Like you measure a line in centimeters or inches. We measure force in newtons, named after Isaac Newton. And there's another unit of force that is called dyne. We won't be going into the details, but for the examination purposes, 1 Newton is equal to 10 to the power 5 dynes. As you can see here, 1 Newton is equal to 1,000,050 dyne. Effects of force. It can start or stop the motion of an object. So like supposedly there's a car and it's moving down the road and there's a huge force acting against it. Supposedly there was a wall, there was a barrier, okay, and the car crashes into it and there's an opposing force. So force can start or stop the motion of an object. It can change the speed and direction of an object. So like we say, supposedly your friend is riding a bicycle and you push him, his speed increases. And direction, supposedly you are skating and someone pushes you from the side. You are going in this direction and now you're going in left direction. Force can change your direction. It can change dimensions. There are various types of forces. We classify them into two: contact forces and non-contact forces. Contact means with touch, and non-contact forces mean no touch. Alright, so let me tell you. Contact forces, they require contact, they require a proper touch between two objects. This is a point of contact. Supposedly there is a notebook and there is a pencil. Okay, a pencil and a notebook, they are constantly in contact, touching each other. That's why you are able to write. Now there are two types of contact forces. One is a muscular force, one is a frictional force. A muscular force is the force you apply with your muscles, through your body. Supposedly there is a boy, alright, there is a boy and he pushes something, he pushes a block. That is using his muscles. It is the muscular force. A frictional force is the opposing force. If you're going in this direction, there is something dragging opposite you, that is friction. It is a frictional force. We'll go into the details, just know the names for now. Muscular force and frictional force. Non-contact forces. Non-contact forces are these three: magnetic forces, electrostatic forces and gravitational force. I will go into the detail of each and every one. Now muscular force. Force due to muscles. Example, walking, your legs are exerting a muscular force. Jumping, again your feet are exerting a muscular force. Through that, this boy is going up. Climbing, if any of you has tried climbing, you exert your muscles, you use your muscles to grab onto the wall, to climb a ladder. Okay, a frictional force. If we try to slide or skate over a surface, the motion is resisted by contact. What that means is, supposedly you are skating, or if we go back to the slide, supposedly over here, this boy and this boy, this you can see this one is skiing, all right, and this one is standing on the grass. Although they are both trying to slide, one will slide more easily, one will slide, one will not slide. All right, he's on grass, you can't slide on grass. Why is he sliding on the snow? Because it has less friction, it is slippery, it has less friction, there is not much resistance to this. Although on the ground there is a lot of resistance, he won't be able to move. But on ski, you see the ski, he will be easily be able to slide. All right, this is friction or frictional force. You are able to walk because of frictional force, otherwise we won't be able to walk. Why? We exert a force in one direction and there is something resisting in the opposite direction. That's why we are able to walk forward. It is what opposes the motion of another body. Alright, so if you have a car or maybe a bicycle, if you have ever ridden something, when you're going in one direction, there is wind acting against you, alright, and it hits your face. That is friction. The wind is causing friction against your face. Types of frictional force, there are various types of frictional forces. One is static friction, alright. One is rolling friction, when there is a rolling body, alright. Supposedly there is a rolling body on a plane and one down the hill, alright. This will not roll that easily, but this will have a motion of its own. It will keep going down the hill because of gravity and other things, but on a plane you will need to push it. On an inclined plane or down the hill, it will go by itself. Here it has less friction, here it has a lot of friction. We've gone through friction. Yeah, now sliding friction. Have you ever slided something? Have you ever gone down that slide? Alright, in the ground. Alright, you climb the ladder and you go down. Alright, this is sliding. You slide over one substance, but eventually you come to a stop. Alright, this is because of friction. You can't slide down this forever. There will be friction, there will be burn. Alright, sliding friction. Now there is kinetic friction. Just remember the names for the examination purposes. Magnetic force. A magnet exerts a magnetic force on other magnets placed near it. Alright, now here you can see the image of a magnet. Alright, a magnet exerts a force, it's a pulling force. Alright, when it's attracting, it's a pulling force. North south attract, north north repel, like repel, unlikes attract. Alright, so here you can see it has attracted everything around itself, that is metal. Alright, and this force of attraction or repulsion, what do I mean by repulsion? Supposedly there is south, alright, south and south, you put that together, it will repel, it won't connect. Alright, that is repulsive force. If I put north and south, that will attract, that is attractive force. So a magnet exerts a magnetic force on other magnets placed near it. If I put any iron or anything metal, any magnetic thing near this magnet, it will attract. Every body containing mass attracts another body. This is the law of the universe. Every body that has mass will attract something of lesser mass, or it will have a more attractive pull, that is magnetic force. That is magnetic force. Electrostatic force. A stationary object, what do I mean by stationary? It is not moving. Not moving. Alright. So a stationary object that has electric charges means, I'll tell you what do I mean by electric charge. On itself is electrically charged object. Try that one time. Take a scale, a ruler, rub it on your head. Alright, rub it on your, like there's a boy, alright, he has hair. take a ruler, alright, rub it on your hair, alright, it will get electric charge on it, alright, it will have electric charge on it. Or take for example a rod and rub it with wool, alright, some charge will be transferred, like here it was on your head, now it is transferred to the ruler. In case of wool, wool had some charge, electric charge, alright, it is now transferred to the rod. Here we have taken the example of a balloon, alright, earlier it was a plastic balloon, I rub it on my head, alright, I have electric charge. The human body has electric charge. If I rub it on my head and I put it near some paper, alright, bits of paper, this is static. I will pull this pieces of paper towards the balloon. Why so? Because the electric charge is now being transferred. Force exerted by an electrically charged object is called electrostatic force. The force being exerted by this balloon which had electric charge, it is an attractive force. It's pulling the bits of paper towards itself. So this attractive force is electrostatic force. It can be repulsive in nature as well. Two bodies need not be in contact to have electrostatic force of interaction. Alright, you see, like, I did not touch this balloon to the bits of paper. It was already in close quarters but not in contact. Now we move on to the next slide, which is gravitational force. So gravitational force, the name itself suggests gravity. Each body in this universe will attract every other body with a force. This force is called gravitational force. Earth attracts the moon. Earth attracts us. You can see in this picture, this is a picture of 4 skydivers and they are being attracted towards the earth. This is the earth. They are being attracted towards the earth. We all have heard about Isaac Newton and an apple fell over his head. Alright. So what was that apple? It was being attracted to the earth. This is the earth and it was being attracted to the earth. Alright. Every body in this universe that has mass will attract every smaller body. It will attract. Alright. The earth revolves around the sun in an orbit. This is due to gravitational pull. Apple falls from the tree because the earth attracts the apple towards itself. Now we come on to a next topic, which is pressure. Now this is all being related to force. Pressure is also a force but acting on a particular area. I'll show you this. Supposedly there is a force, okay? You do a pushing motion, right? And on this particular area, okay? This is being shown here pe area. Alright, if it's a nail, supposedly it's a nail, it will go inside, right? Why? Pressure is force acting perpendicularly मतलब at 90 degrees straight ऊपर से, this perpendicularly, alright, perpendicularly on a unit surface is called pressure. I put some force on a particular area, supposedly this is the area, I put some force on this particular area, unit area. This will be called pressure. It will not be called force, it will be called pressure because area is involved now. Alright. Earlier we were only talking about attraction, repulsion, pulling, pushing. Now we are talking about putting force on a particular area, a stationary piece. Stationary means not moving. Pressure is equal to force upon area. Remember this formula. P is equal to F upon A. P is pressure, F is force, A is area. The international unit for force per area, that is pressure, is Pascal. Okay? Named after the scientist Pascal. CGS unit, it is bar. Alright. Now we come over to density. So density, dense, as the word suggests, we talk about the how dense means how many molecules it is packing. See, density's formula is m upon v. All right, mass to volume. It is a ratio, mass to volume. All right, mass divided by volume. More mass means more density. All right, more volume means less density because this is in the denominator. All right, m by v. If m increases, okay, d will also increase. v increases, okay, denominator will increase, this whole value will decrease, so d will decrease. All right, here you can see supposedly this cube, all right, it is the volume, it shows volume. All right, and these circles are molecules. Okay, here we can see there are less number of molecules, here we can see there are more number of molecules. This is less dense, this is more dense. Solids are more dense. Right, just a minute. Solids more dense than liquid. All right, density of water. All right, supposedly this is a molecule of water. Water's density is maximum at this temperature, 4 degrees Celsius. Let's go on to the next slide. Now we have some advantages of friction. All right, what does friction help us in? Friction helps us in walking. All right, friction between our shoes and the ground helps us to walk without slipping. Friction allows us to write. I'm writing because of friction, because the pen is able to glide over the surface, and this is friction. It helps us in gripping. Have you ever gripped a bar, a pull-up bar? All right, you won't be able to grip anything if there was no friction. You won't be able to pull yourself up because there is no friction. All right, it helps us in braking. If you're riding your bike, if you're riding your car and we apply brakes, there is resistance to the wheel. All right, supposedly this is a wheel. All right, this is your cycle's wheel. Go home and see there are brakes attached to this. All right, this is a cycle. यहाँ पे brakes होते हैं ना, you see you have brakes. When you press this, this is attached wires and this will engage, the braking will come in contact with the wheel and it will create friction which will lead to stopping. All right, it enables us to climb, it gives us stability. Now there are several disadvantages of friction as well, which you need to remember. Causes wear and tear. Since it causes rubbing, it causes heat, rubbing, it will lead to wear and tear. Wear and tear का मतलब it will lead to damage, it will lead to loss. Due to supposedly this machinery, we oil our machinery. Why do we oil our machinery? So that we can reduce the friction between the parts. Alright, if there is more friction, the parts will get damaged more easily. It produces heat, it creates resistance, it wastes energy, it wastes a lot of energy. Friction wastes lots of energy. Friction converts useful energy into heat energy, resulting in the loss of energy. Supposedly you apply your brake. Alright, you apply the brake, there is friction, friction leads to heat, brake will get damaged. Alright, increases effort. Since there is more friction when you're running, when you're skating, when you're sliding something, you need to push more, you need to put more force. in order to overcome that friction. Alright, if I'm putting a force of 50 Newton and there is friction of 60 Newton, alright, which will come in a negative sense. Alright, 50 minus 60, it won't move, but it will give me an opposite force in the opposite direction. Okay, if friction is more, the force coming from the opposite direction is more, it will lead to me being overcome by that force. It will be minus 10. All right, supposedly I am pushing something of 50 Newton. All right, I am applying a force in this direction. There is friction coming of 60 Newton from opposite direction, means I will go this side more. Supposedly if it was 50 Newton going in this direction and friction was only 10 Newton, alright, coming from this direction, it's the opposite force, I will still be able to go this way. I will be able to overcome this 10 Newton. Alright, so if there is more frictional force, it increases effort. I will need more force. I will need at least more than 60 Newtons to overcome this. If it was equal to 60, now supposedly I put 60 Newton from this side and from opposite side also I get 60 Newton. This will cancel out. Plus 60 and minus 60. Minus because this is coming from the opposite direction. Opposite means minus. Plus 60 because I was going in the right direction. Plus and minus cancel. This will be 0. Alright. So it won't change. It won't change position. It causes noise. Have you ever seen your door? Alright. When the door has become old, it needs repairing, it needs oiling, it will do a screeching noise. Alright, screeching noise, that is due to friction. Alright, the hinge in your door is making noise due to friction. Now we go to atmospheric pressure. We learnt about pressure, we learnt about density. On our earth we have atmosphere around. Alright, atmosphere has a lot of layers, has a lot of chemicals, gases, has a lot of air. Alright, this is our earth. Alright, this is the earth and here is atmosphere. This atmosphere we know has a lot of air and weight. Since it has weight, it exerts pressure on surface of the earth. Weight means force acting on area. You have mass, you have weight. Alright. Since it has a lot of weight, it has a lot of force exerting where it stands. Alright. If you are someone of 100 kg, alright, you will put a lot of force on the ground. Okay. And similarly, our atmosphere also puts a lot of pressure, a lot of force. Alright, so, if you remember, pressure is equal to force upon area. F increases, force increases, then similarly P will also increase. But if the denominator increases, D increases, this whole value will decrease. Okay, so if area increases, pressure decreases. I'll give you a good example. Supposedly there is a fruit, supposedly there is apple. Alright, I want to cut it with a knife. Okay, knife sharp, if the knife is sharp, it will cut easily. If the knife is blunt, alright, if it is a blunt knife, it will not be able to cut. Okay, it will have some difficulty in cutting. Why? Because the area here has increased. If area increases, the force applied will decrease. It will get distributed, okay, on the surface. So if you can see it everywhere, alright, just keep that in mind. When area is less, force will be more and thus pressure will increase. If area is increasing, then applied force will decrease and pressure will decrease. Okay, as we go higher and higher on the surface of the land, the atmospheric pressure keeps decreasing. For example, supposedly this is the land, it has mountains. Okay, this has mountains. I'm drawing very big, but you can understand it. If you're standing over here on top of the mountain, there is less pressure, okay, as compared to someone over here. Yeah, here is less pressure, here is more pressure. Alright, why? Because here more air is acting, here you have already overcome so much air, it has less pressure. For example, there is less pressure on mountains, the air is thinner. If you've ever been to the Himalayas, air is thinner, there is less atmospheric pressure, and it is an important question. It is difficult to cook. Alright, why is it difficult to cook? Because atmospheric pressure is less. You can't cook with a pressure cooker over there. There is no pressure. There is not that much air pressure at high altitudes. Alright, if there is a building like supposedly a tower, alright, I'll draw it. If there is a building, alright, you are over here, less atmosphere pressure, less atmospheric pressure. Atmospheric pressure is measured using a barometer. Alright, do keep in mind because devices can be asked. At sea level means at the level of the sea. Alright, supposedly this is an island and trees and all. Alright, this is at sea level. Alright, at the level of the sea, there is no land. We are not elevated from the sea level. We are on sea level. That is a minimum benchmark or a minimum level that we use to calculate how much further are you in the atmosphere, how high are you above the sea level. Sea level is the basic. So at sea level, the atmospheric pressure is 1.013 into 10 to the power 3 Pascal. Alright, 1.013 into 10 to the power 3, that will come around 1013 Pascal. At sea level, if you are at sea, if you have ever been to Goa or anywhere, if you are at sea level, then the atmospheric pressure, the pressure that the atmosphere is putting on you is this much. Now we come to relative density. It is the ratio of density of a substance. Now you remember density. Density is how many molecules, how much dense is in how much density is in a particular volume. Alright, if you are a substance, if you have a bottle of water, alright, the liquid has less molecules, it is less dense as opposed to something more density, something of higher density would be sand. Alright, it has a lot of particles, that has more density. Okay, now density of one substance, supposedly sand, with respect to divided by density of water at 4 degrees Celsius. We all know that density of water is maximum at 4 degrees Celsius. Okay, relative density, relative means with respect to something, in comparison to something. Okay, here it is a ratio. In mathematical terms it is a ratio, but what we mean by this is density of one substance, supposedly sand, okay, in comparison to density of water at 4 degrees Celsius. This will give me the relative density of sand. It is measured using a hydrometer. Remember the name. For example, ice has a lower density than water. I know you will say it is a solid, but it is not. It has a lower density than water. Thus it floats over water. You can be asked this anytime. Why does ice float over water? Ice floats over water. Supposedly this is a cup of water, okay, and this is ice. Okay, it will float. Okay, it is a little bit submerged. Okay, supposedly this is it, and it is a little bit submerged, but this is the ice, this is water, this, okay. Ice and water. Ice will float over water. Why? Because it has lower density. Always remember, it has lower density. Now we come to the next slide. Buoyancy. Okay. What do you mean by buoyancy? I think you've all been swimming. Okay. You've all at least tried to float. Why are you able to float? This is due to buoyancy. Okay. This is all due to buoyancy. Upward force acting on a body immersed in fluid. Okay, now I'll tell you, supposedly this is a swimming pool, okay, and you are trying to swim, okay, you are trying to swim, okay, legs are moving, everything. A part of your body is submerged in water, okay. Now the liquid will exert a upward force over your body. You are putting a downward force, it is putting an upward force. This upward force is called buoyancy, okay. Buoyancy. Okay, it is a property of a fluid. A fluid is buoyant. This is also called upward thrust, upthrust, or buoyancy or buoyant force. Remember that. It depends upon the density of a fluid and not on the density of the body. This can be as dense as you want, okay, this can be as dense as you, but buoyancy depends on the density of fluid. Not only water, anything liquid, okay, it will have buoyancy. It will put an upward thrust on the body that is immersed into it. For example, exclude the spelling of example. During swimming, the body displaces water by hands and legs, and thus total weight of water displaced is equal to weight of the body. When you are swimming, you move your arms, you move your legs, you displace some water. What do I mean by displace? Some water gets thrown out, some gets splashed, all right, some gets splashed. All that displacement is equal to the weight or force that you are putting on the water, all right. So for example, consider ice floating in water, okay. Does water level change after the ice has melted? No, I'm not talking about that condensation that happens after you see water droplets on the outside surface, okay. No, not that. I'm talking about ice that was inside the glass, okay, and water is at a certain level. After this ice has melted, after this ice has melted, okay, this water level will still be the same, it won't change. You might think that water level will increase, it's not like that, okay. This is all due to buoyancy. The amount of water that has increased once you drop that ice, into the liquid, all right, it has reached a certain level and it will stay at that level, okay. Ice is floating due to buoyancy, you're putting an upward force. It is easier to swim in sea water because its density is less as compared to normal water. Another thing, like I said, it is based on density, okay. Sea water, you will be easily, as compared to normal water, you will be easily swimming in sea water. Why? Because its density is less, okay, as compared to normal water. Thus, it is easier to swim in the sea water. Always remember this. This is a one marker. Surface tension. It is the property of or tendency of a liquid surfaces at rest. Supposedly, I have dropped some water from my bottle, all right, on the floor, okay, and it has some surface, okay. The property of surface, the property of liquids is that once this liquid is at a state of rest, stationary, not moving, it has spread over a surface, okay, it will take the lowest possible area, okay, on this surface, okay. Drop a droplet of water, okay, it will take this form on the surface. It won't be going like this, like this, like this. It will take a shrink to the lowest area possible. This is due to surface tension. All right, the water droplet is pushing itself to the center, and thus it remains in a particular shape. This is due to surface tension. The molecules are trying to come to the center, okay, from every direction. Supposedly we are viewing from the top, okay, and this is coming this way, this way, this way. This is one water droplet, okay. Surface tension, it is what allows smaller objects with higher density than water. Supposedly, now you know that if something has a higher density than water, it should sink, okay. If something has higher density, it is a solid, it should sink. But why is it not sinking? This is due to surface tension. Why are we not sinking while swimming? A lot of things: surface tension, buoyancy, density. We have a higher density, yeah. Water. So like if you can see over here, a paper clip or a mosquito, you can see here a mosquito, he's floating on water. All right, he is not drowning. This paper clip is not drowning, okay. If you throw a paper clip at sea, it will keep floating, it will not drown. Why? This is due to surface tension, okay. And these things might have a higher density. It is a solid, it is also solid, it has higher density, but the property by which these things do not sink is surface tension. Always remember that. It also justifies a few things: the spherical shape of a raindrop, because there is surface tension acting against it, okay. Insects and mosquitoes swim on water surface due to surface tension. If surface tension is high, all right, surface tension is very high, these things will float, they won't sink. All right, so this much for today on the theory class. I will also have an example session where we will be discussing questions, but do go through this, do get a basic gist of it, and thank you.